I'm gonna use an acrylic disc. It's a 1/2 inch thick acrylic disc in a very bright 1000 lumen flashlight, for which I made a little adapter to make it a little bit like a beam, to see if I can show how rainbows form. So in the rainbow you see a primary rainbow, which is much brighter at about between 41 and 43 degrees, and then another secondary rainbow that seem to have reverse colors, that's usually a little higher and tends to be a little dimmer in color. So I'm gonna move the flashlight until I get rainbow color. So the light is gonna be refracted here at the interface between air and the acrylic, then total internal reflection. It's gonna reflect it once, and then it's gonna be refracted once again when it leaves this representation of a water droplet. So if I move the light around, get to an angle that maximizes the constructive interference of different colors right here. As you can see, rainbow pretty clearly. So this is a primary rainbow. And here I played with the flashlight and the angle in which it enters the raindrop to see if I can get the secondary rainbow to form. So the sun's light enters the raindrops from the bottom to form the secondary rainbow. They refract. There is one total internal reflection. That beam reflects again, second total internal reflection at the top here. And then that reflected beam leaves and refracts again. So upon entering the raindrop, the light disperses a little bit, with blue light bending more than red light. And then through the reflections and eventually by leaving, you can actually see the dispersion. So these are gonna be the order of the colors. So the bottom blue and the top red for the secondary rainbow. And using lasers through the acrylic, you can show a little better the path the light would take to form the rainbow. You can show the total internal reflections here. Kind of have to play with it a little bit. So primary rainbows form from one total internal reflection within the raindrop, and actually two refractions, right, in and out. Secondary rainbows form from two total internal reflections inside of the raindrop and two places where the light refracts. So why is the order of the rainbows opposite? Well, first, for the primary rainbow, you might notice that we don't see the dispersion in the order that we see it in the raindrop. So the top color in the primary rainbow, the red, comes from the highest raindrops that give us these the red rays of light. Okay. And then for the secondary rainbow, it's exactly the opposite. So the top color for the secondary rainbow is gonna come from the highest points, the highest drops in the sky, which means we're also gonna see that the blue light that emerges on the bottom after the dispersion.